Hello students, today we are going to start chapter 2, Polynomials. This term is not new for you because you have already done this chapter in 9th standard. This is the extension of that chapter. Here, this is the general form of a polynomial in one variable. Px is equal to a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus so on, and at the end a n minus 1 x plus a n, where n is a positive integer and a naught, a1 to a n, all these values are constants. Meaning is very simple, that any value of x cannot have the value or its of n, which is its exponent, as negative value and fractional value. And if the value of n is negative or fractional anywhere in this polynomial, that will not be a polynomial, it will be a simple algebraic expression. And a naught, a1, all these values are real number which can be positive, negative, or as you all know, comes under any real value. Now, the types of polynomials. Linear polynomial. General form is ax plus b, where x is the variable and the highest power of variable is 1. Quadratic polynomials. General form is ax square plus bx plus c, and the highest power of variable is 2. And where the highest power of variable is 3, that is cubic polynomial. And where the highest power of x variable is 0, that is a constant polynomial or zero polynomial, because it consists of only a constant value. Now, another term which is very common in this chapter, and we will frequently use that term, is zeros of a polynomial. Linear equation will have maximum 1, 0. Quadratic polynomial will have maximum 2 zeros, and cubic polynomial will have maximum 3 zeros. And the zeros will be zeros of a polynomial px, which is a polynomial, maybe linear, quadratic or cubic, are precisely the x coordinates of the points where the graph of px intersects the x-axis. It means that when we draw the graph of these polynomials or any polynomial, we look into the points where the graph is touching the x-axis or intersecting the x-axis. And at the number of places, how many places it is touching or intersecting, that number will be the number of zeros of the polynomial, and the particular value of x coordinate of those points will be the value of all those zeros. If I explain you in another form, let us suppose that px is a linear polynomial and we place value minus 3 at x, so it becomes p minus 3 equals to 0. Now minus 3 is a zero of polynomial px. Another, suppose example, px is x square minus 2x plus 1, and I place 1 in place of x. So 1 square minus 2 into 1 plus 1 gives you 0. So here 1 is 0 of this polynomial Px. So for the value of x, if polynomial becomes 0, that value of x is called 0 of a polynomial. So this is all in session 1. In session 2, I will explain you about relation between a, b, c, d and the value of zeros. Thank you very much.